Hello and welcome to Monday's warm up. All right, so we've got our two-way table here. Not even going to read the question. Why am I not going to read the question? Because here's my advice. If the two-way table does not give you totals, your very first step should be to put in the totals. All right, so I'm going to put a 36 here, 20 plus 7 plus 9. I'm going to put in a 68, 88, 97 here. I'm going to put in a 49 down here. I'm going to put in a 32 over here. I'm going to put in a 52 right here. And I'm going to put in a table total of 133. So again, always a good idea to put in the table totals if they don't give them to you, because more often than not, you're going to need them anyways. All right, so let's actually look at the question. Recycling helps save resources. Some people think recycled products are lower in quality. These people hate the earth, quite obviously. People who use recycled products obviously love the earth. They have different opinions from those who don't. Here are data on attitudes on recycled products from people who do and don't purchase them. All right. So how many people does this table describe? Oh, wow. It's a good thing I put in these totals. That makes this question really easy. All right. It describes 133 people. Wow. Really good advice on my part. How many of these people were buyers of recycled product? Well, again, across the top is their opinion. Down the column is whether or not they were buyers. So these are all our buyers. Wow, it's really good that I put those totals in. That just comes in handy again. So how many of these people were buyers? That would be 36. Okay. What is the marginal distribution? So throwing some vocab of opinions about the quality of recycled products. What percentage of people think the quality of recycled products is the same or higher than regular products? So if I'm looking for the marginal distribution of opinions about recycled products, that basically means that I'm pretending we didn't even bother to ask whether or not they bought them or didn't buy them. We only care about the opinion data. The other breakdown is irrelevant for us. So what that means is that higher, we're going to use the values at the margins. We're going to do the 49 out of 133. The same is going to be 32 out of 133, because again, marginal distributions are always over the table total, and lower is going to be 52 out of 133. So I'm totally ignoring whether or not they bought or didn't buy. I'm just focusing on the opinions. All right. And this works out to be like 36.84%. This one works out to be 24.06%. This one works out to be like 39.10%. So that would be my distribution of opinions. And then when it says what percentage of people think the quality of recycled products is the same or higher, all right, that would just be us adding these two together. All right, so that's all that's going on there. So that would give us 56, 60.9, I believe. 60.9% think it's the same or higher. Okay, so find the conditional distribution of response type. So that means the percentages that we calculate are going to be referring to response types. And then it tells us to do it for both buyers and for non-buyers. All right, so basically what I'm doing is I'm limiting myself to just buyers, and I'm calculating those three percentages, one for each opinion, and then I'm going to repeat the process for non-buyers, calculate three percentages, one for each opinion. So for the buyers, all right, I'm just going to do high, same, and low. All right, I'm limiting myself to that single row. So high would be 20 out of 36. The same would be 7 out of 36. Lower would be 9 out of 36. All right, and then if we're doing that as percentages, I can do this one in my head. That's 25%. This one's 19.44%. And this one right here is 55.56%. So I've limited myself to the buyers, and then I've given the distribution of response type. This is the percent higher, this is the percent same, percent low. I'm now going to do the same thing for non-buyers. I'm going to limit myself to just the non-buyers, and then I'm going to calculate the distribution of opinion types, which means I need percentages for high, same, and low. So this is going to be 29 out of 97 because I've limited myself to just this row. It's going to be 25 out of 97, and it's going to be 43 out of 97. So again, as percentages, because that's going to help us compare them, we've got 29.90%, we've got 25.77%, and we've got 44.33%. So using your calculations above, what can you conclude about the association between our two variables? So we can see that the conditional distributions are different, which must mean there's some association. So in this one, it seems pretty clear that people that buy recycled products have a much higher opinion of them. All right, this is 55.5 compared to 29.9. And these are both lower, but all of that kind of extra percentages is floating up here. So people who buy recycled products have a higher opinion people who don't have a lower opinion. Now, that might seem kind of obvious, but as a researcher, what you're now interested in is, okay, why? Now, do they have a higher opinion because they've bought them and they've realized they're just as good? Do they have a higher opinion because they're more environmentally conscious? And then the same thing over here. Like, yes, non-buyers have a lower opinion. It's kind of what we'd expect. Otherwise, they'd be buying them. But why do they have a lower opinion? Did they try them and not like them? Or have they not even tried them? Do they just have like a predisposition against them? Right? Again, that would be sort of the follow-up question as a researcher that you'd want to ask. Now that you know that there's a legitimate difference in their opinions, all right, what's driving that distance, because if you're trying to market these things, either for your company or for just the planet in general, you've got to figure out what's causing this and then trying to address that. Do you just need to better advertise them, or do you actually need to improve the product so that people are more willing to buy them? All right. And that's for a follow-up study. All right, flipping over to the back. Most baseball hitters perform differently against right-handed and left-handed pitching. Consider two players, Joe DiMaggio and Derek Jeter, both of whom bat right-handed. The table below details their performance. Show that Simpson's paradox holds, i.e. that one player hits better against both-handed pitchers, but lower overall. All right, so we're just going to calculate some percentages here. So we've got Doe and how Doe does against righties, how Doe does against lefties, and how he does overall. And then we're going to do the same thing for Jarek. We're going to see how he does against righties, how he does against lefties, and how he does overall. So Doe against a right-handed pitcher has 40 hits out of 100 at-bats. So 40 out of 100 is 400. Against lefties, He's got 80 hits out of 400 at-bats, which works out to be 200. All right, now if we go down here and do the same thing for Jarek, Jarek had 120 hits out of 400 at-bats, which works out to be 300. And against lefties, all right, Jarek had 10 hits out of 100 at-bats for an average of 100. All right, so if we look at this, Doe hit better against righties, but had much fewer at-bats against righties, only 100 via 400. Doe hit better against lefties, but had way more at-bats against lefties, 400 to the 100 of Jarek. So we're probably going to see Simpson's paradox hold here, because even though this 200 is higher than the 100, it's going to be weighted more heavily because it was 400 of Doe's at-bats. This 100 is lower, but it's only 100 at-bats. Over here, we've got the same thing. Yes, Doe is higher, 400, but it's only 100 at-bats versus 400 at-bats here. So this 300 for Jarek gets a lot more weight than this 100. In contrast, for Doe, this 200 gets a lot more weight than this 400, so it's probably going to cause the relationship to flip. So overall, Doe has 120 hits out of 500 at-bats, which is good for an average of 240. And then overall, Jarek has 130 hits out of 500 at-bats, which is good for an average of 260. So we are seeing that reversal where Jarek is lower against righties and lefties, but higher overall. Doe is higher against righties and lefties, but lower overall. And again, it comes down to that weighting. All right, Doe's 200 is weighted much heavier than Jarek's 100 is, and then vice versa over here. All right, so again, that's Simpson's paradox. It's just something that can sometimes pop up when you have discrepancies in group size that lead to some unusual outcomes. All right, final question here. The National Survey of Adolescent Health interviewed several thousand teens. One ridiculous question they asked was, what do you think the chances are you will be married in the next 10 years? I mean, which teen actually knows that? Here's a two-way table of the responses by gender. All right, so we've got females as our column variable. We have their opinion as our row variable. This table already includes the totals, so that's great. It says, use the above data to sketch a segmented or stacked bar chart. Those are the same thing. For the conditional distribution of response type for each gender. All right, so this table here is just so that we can calculate those percentages, and then we'll use those percentages to actually make our chart. So again, if we're doing the conditional distribution of response type, all right, those are the percentages we're going to calculate, and then we have to do it once for each gender. So we're going to say, all right, looking at just females, what is the range of response types? And then again, looking at just males, what is the range of our response types? So we're going to be doing 119 over 2178, which should give you 5.46%. Then we're going to do 150 over 2178, which should give you 6.89%. Then we're doing 735 over 2178. So that should give us 33.75%. And then we're doing 1174 over 2178, which would give us 53.90%. So all of these are over the 2178. And then when we move over the male column, they're all going to be over the 1740. And we just go down and do them one by one. And you should get 5.92%. You should get 9.83%. You should get 40.80%. and you should get 43.45%. Now, as far as the stacked bar chart goes, here we have our grid. All right, a stacked bar chart is always going to add up to 100%. So there's 0%. We'll call that 25%. We'll call that 50%. We'll call that 75%. And we'll call that 100%, because each bar represents all of these summed together, and these are always going to add up to 100%. So we're going to need both a female bar and a male bar. And then we're going to go through, and you can either do them in the order of the chart. Let's just do them in the order of the chart. So we'll start with no chance. All right, but you want to make sure they're in the same order. So like if I do this one, no chance, some chance, good chance, definitely, I should do this one in the same order. Or I could go in the reverse order and do definitely, good chance, some chance, no chance. But we'll just go from top to bottom. So no chance is about 5%. All right, and it's a good idea to label these. So I'm going to put like a little NC in there. And then we've got another 6%. For some chance, so there's that 6% on top of the 5%. Then we have 33.75. So that's going to bring us just a little below 50%. And this is our good chance bar. And then the rest of it, which is going to go up to 100, because a stacked bar chart always goes up to 100, is going to be our definitely. All right. And then we would do the same thing over here for male. All right, so this first one is pretty much going to look the same because they're both about 5%. All right, this some chance is going to go a little higher. It's still not very high, but it's going to go a little higher because it is the 9% there. Then the good chance is going to go up above 50% by the time we add those three together. So there's our good chance. And then our definitely is going to be the rest of it there. All right. And just for the record, when I ask you to sketch a graph, I'm not going to be breaking out my ruler and making sure that every line is exactly kind of where it needs to be. A sketch, I'm just looking for the general idea. And as long as the general idea is there and there's no glaring errors, you're going to be fine when I ask for a sketch. If I ask for like an accurate graph, and yeah, it needs to be accurate. But if I just ask for a sketch, I'm looking for the general gist of it. This is a little bigger than this. This is bigger than this one. This is smaller than that one. Like I should be able to kind of see the relationship, even if it doesn't exactly line up. It's not like I had a ruler or actually spaced these things out evenly. So again, just when I say sketch, it doesn't have to be perfect, but it should have the main information and it should represent what's going on. All right. So that's it for today. Well, that's not it for today, but that's it for the warm-up. Hope this was helpful. Later.